Go to the next day.
Exactly.
I might just like plug it.
We have to write how to assemble this and the procedures.
I know.
Not even. The
How do
fire
you-
was around
Stick
there.
it in.
No, but you got this. How
I would
to
love to set my own.
You're right, clamp.
mess with it.
Fires are cool.
Oh, how do you?
Let me.
And then how do you put the bottles in?
How do you have a dead person?
It's called a well
okay.
plate.
How would you
It's called
describe
a 1,
it?
2, 3, 5, 4.
On
This is
screen,
12
if you write
well
that.
plate.
Stick the ring stand inside the burette.
Wait, the ring stand was here by itself, so you have to buy the burette clamp separately. And then, you are so intellectual.
I don't want to get jumped.
Mohammed, what did you make here?
Take a video.
Give us your
Well
phone.
played. 12. You have the most storage out of all of them.
Don't drink my Coke.
I wonder.
Now, what if your saliva contaminates that and it becomes more acidic?
Wow, that's
Is that one of your discussions?
We'll put it in discussion.
That was the messiest lab I've ever seen.
Mohammed is like his failing or something. He's like,
According to the balance equation, morning goals of
My ears might start bleeding.
my stink.
Might start bleeding.
I don't think that's good.
It's the same lab? Yeah, he's putting an indicator.
I thought she actually did something.
I did. Oh shit, that could have fallen into
Error that could have fallen into you.
What if I throw
I know.
My phone was right there, but
methyl right in it?
The second question, I did it wrong, and then she
I just got sniped.
Watching him get into the phone.
You didn't catch it.
That's how you guys the
That thing was like this big.
That's how you guys the answer.
I think so. I just forgot.
I guys did it wrong. It was like 7 times 2.
Yeah, I don't know. I overcome it.
I think you guys were so bad.
No, Joseph got it right. 7 times 2.
Yeah, it was like how much sodium, how much of the base value of sodium did you get?
What's that? Why is it pea colored again?
Everything is pea colored.
This is gonna be good.
That's like
You had some. What did you have? You had the. You had the peach tea or something? Yeah. Bring it. Okay. Or half and half or whatever.
Say goodbye to your drink. It is going to be used for lab purposes.
how much sugar is green?
A lot. It's like
It's only 35
Which
grams.
indicator is
Only
best.
75%.
So. So because I wanted to figure out which end, put a little bit. Just a little bit. You can drink the rest. That's good. All right.
Jay, did you already drink out of that before you gave it to him?
What is that?
Okay.
That could have been in our
Yeah, that could
Discussions
Yep.
has spit.
Jay's acidic saliva.
It's like half empty. That's geography.
Why are you recording like a mom like this? I don't know what it's school can't say.
I cannot find anything.
Yeah. So for the darker stuff, so what I did here was I figured out which indicator is best. So I want an indicator to change color that makes me see that it's obvious, you know? So the soda clearly and the tea clearly showed that it is yellow, right? You guys are seeing that it's yellow already. Like this is yellow color and the soda is kind of like yellowish or orangish color. So in order for me to see the change and make it neutralize, I have to use an indicator that, I know that for sure these are all acidic drinks. So in order for me to see an indicator that is that's going to be effective, I have to see an indicator that actually changes colors clearly. So I use methyl red. Methyl red is red when the solution is acidic, but will turn into yellow. So when I put methyl red in here, you can see that the solution is red. When it turns into yellow, it will turn into yellow when the pH is above 6. Which is kind of like that's the neutral point, you know what I mean? So I'm going to use the methyl red now in order to assess the how acidic this Snapple tea and this Coca-Cola is. Okay. So what are we gonna do? We're gonna try to use a burette, but these burettes are probably very dirty. We're gonna have to use some new ones. All I need is just a little bit of. All I need is a little bit of, you know, what do you call it? Sodium hydroxide, and maybe about 10 milliliters. So I'm gonna.
Just slide it in.
Yeah. So in order for me to make sure that my solution is standardized, I'm gonna not even actually try to. I'm not even gonna try to dilute this thing, or I can dilute it with a. So right now this is a 2 molar. Maybe I should dilute it. Yeah. So it is a 2 molar. I'm gonna dilute it to 1 molar. So we're gonna make it like exact. You know, we're gonna make it perfect. Last time we made it all right, but I think we can make it better. So if I use, I'm gonna do a 1 to 3. 25. So if I do a 1 to 3, if I do 10 milliliters of here and I add 20 milliliters of water, I think that will do the trick. Or shall we do more? 10 to 4, that will make it a 0.5 molar, right?
Yeah.
Because it's a 2 molar. So if I do 10 milliliters of this and then add 30 milliliters of water, it'll be 1/4. Julia! Will be 1/4 of sodium hydroxide, right?
Yeah.
1/4 of sodium hydroxide will make it 0.5 of the 2, because it's 2 molar. You understand or no?
Yes.
Okay, good.
It's 2 molar.
Yeah.
Okay, so
10 milliliters of it. Just do M1.
so we're gonna make it. So we're gonna make it a 0.5 molar.
10 milliliters. The right
Yeah.
side
Now I'm gonna try to put exactly.
Funnel.
No, 50 milliliters.
It's right there.
But no, we gotta get
I don't know how clean
Because we don't know.
I'll clean it for you.
Okay. Use a funnel.
It's supposed to be
That's illegal.
No, keep it up.
That's not proper lab etiquette.
20.
Wait.
When you've been doing this as much as me,
No, I meant 40. Wait.
I swear he's gonna get his chemicals taken away.
The district that come and be like,
He's saying.
Wait, what?
He said it's 10 milliliters, and then he's gonna add 30
I swear he looks like a mom at his
He's
school.
gonna add 30 milliliters.
face?
So what's the point? Why is it on 30?
so we
No,
got.
it's 40.
It
They're
looks funny. You
combined.
think I'm funny?
Volume is 30 milliliters. I mean 40.
It's like dangerous.
Yeah.
You're supposed to toss off the rest of it. Who said don't pour sodium hydroxide down the drain?
My MSDS.
Don't pour sodium hydroxide down the drain? This is a 2 molar sodium hydroxide. You can easily pour it down the drain.
Yeah, Jalen.
All right, we got exactly 10 molar. Sorry, 10 milliliters. We got exactly 10 milliliters of sodium hydroxide. All right, and now we're going to confirm. So this way you don't shoot at me in a discussion. Make sure it's 10 milliliters.
Don't drink it, Maz. Why would you make Maz do it?
damn!
Put it on the table.
And then bend down.
That's part of the discussion now. Maz read the graduated cylinder.
He bit.
He read the graduated.
Yeah, that's 10.
Thank you.
Guys, I'm not wrong.
Proper lab etiquette.
What is this? Is it
Wait,
gonna
Dark
shrink
Cylinder,
because I
are you
saw
sure
it?
it's gonna be?
It's gonna go into discussion now. It's
Damn,
gonna be.
Wait, so
How old are you?
30 or 40?
So 30 mils of water, 10 milliliters sodium hydroxide, 2 times 10 is equal to
Wow.
X times 40.
Is this 30 milliliters of water?
Wasn't it 30?
No, yeah, it's water. We're going to dilute sodium hydroxide. And they're going to have combined base so we can find the concentration of sodium hydroxide.
There's no
All right.
No, I think it's 1 molar.
There was all bubbles. It's like a
30.
That is not 30.
Oh.
That's 30.
Above 30. Guys, everybody know 30. In the discussions, it's above 30.
It's exactly 30.
That's what I'm saying.
Raise the meniscus.
Put it on the table.
It's 30.
Okay.
Exactly.
I'm trying to figure out how you got the.
Not that guy.
What did I do?
They have a combined weight of 4.
Why is the anti-bond sensitive so much?
It's not anti-malnutrition. You don't have to
Our
know that.
transcript.
No, he chose 10 milliliters.
Okay.
No, he wants to make it 4. So he added, like, he just did it in his head. Because you're changing 10 to 40, which is like 140.
But you're changing to 25. Shouldn't that be your goal? So shouldn't you not have this amount?
No, he already did the math in his head. He knew how much he needed to have.
So if I was just an ordinary student conducting this experiment, I have
Okay.
to do 2.
Times 10.
So guys, what we have here is calm down. Too much energy. So what we have here is, what we did was we put 10 milliliters of sodium hydroxide. This sodium hydroxide is 2 molar. All right, so if you MAVA equals MBVB, molarity of the acid multiplied by the volume of the acid equals the molarity of the base multiplied by the volume of the base. So if you put the 2 molar multiplied by the 10 milliliters, is going to equal to the X molarity. Sorry, M1V1 equals M2V2. I'm sorry. M1V1 equals M2V2. So it's the same really thing.
Yeah.
So 2 molar multiplied by 10 milliliters equals the X molar multiplied by total volume now 40 milliliters, right? So the new molarity is going to be 0.5. And we were very careful with this so that you guys don't torture me in discussion. So now we're gonna put this in here. Can I just put this in here right away, right now?
No.
Guys, can I just put this in here right now? What can I do instead?
Yeah.
Thank
Made the same
you.
mistake.
Guys, if you forgot this step, it's really sad, you know, because now the whole thing is gonna have to repeat the whole thing, you know what I mean? So you wanna make sure that you don't forget.
Can't you just, like,
So this is the base, so I'm dropping the base right now.
imagine?
Be careful.
He's dropping the base.
Alright, I am using 40, so I should have 40 milliliters of what do you call
Sodium
it?
hydroxide.
Of sodium hydroxide, okay? Alright, very good. So we're gonna put this on the side. This is my base with the base. Put it all together. It's already labeled with this. Okay. Alright, and
Can't see behind this. Yes, you can. I have X-ray vision. I can see sodium hydroxide.
okay. Alright, so now what I'm gonna do is I'm going to measure about so I'm gonna do this a little bit differently this time. I'm gonna take out another burette.
Why 10 to 40? Why not?
This is the way it's
Or like
supposed to be
30
done,
to
by the way.
32.
He wanted to make
FYI.
it 40 milliliters.
The way it's supposed to be done is this way. In one section, in one piece, in one burette, you will have the acid, and the other burette you will have the
It would
the
stay the
base.
same
You put the
molarity.
peach here,
If
right?
it was 20 to
Put a
20, it
little
would
more
stay the
peach
same
here.
molarity.
So why not
Let's get a little peach here.
30 to
Don't
10?
put them out.
This is 30.
Oh,
Yes,
yeah.
you would have a higher molarity.
Keep going.
If it's already 2
No,
molar.
it wouldn't even be 30 to 10.
That's good, that's
It just
enough.
has to be a total amount.
Yeah, because we're
All right.
But why is it 10 on the left side? Why is it 10 of all
Excuse me, Mom.
numbers?
Because that's the sodium hydroxide.
On 5.
So
Because then it's going to be a different amount.
that's the second one.
Goal to get 40
We took that out.
So-
to
Supposed
get
to get
0 when
40
you
mils of 45.
How are you supposed to know that you wanted to get 40 mils of 0.5?
That's a lot of bubbles.
He just chose.
Let him do his job, my God.
I'm just making comments for the discussion just in case
We
people
know the
are blind.
molarity.
All right.
Don't know how much we need.
So here's what. So the reason why we do it this way, this is officially how titration needs to be done. The acid is supposed to be in one burette. The base needs to be in another burette. Okay, that's officially how it's supposed to be done. And what we're going to do is we're going to take out a certain amount of the acid from here. All right, this has a lot of bubbles.
How many
That's what it says.
So is that indicative
When I
that
say
it's
it's
an
useless, when the
acid?
doc says it, it's very
No, just a lot of bubbles. It's indicative that it's, I don't know. I don't know what's in the Snapple. Sugar, maybe. Fermentation. These are,
Would that cause a problem?
no, as long as we can read right below the bubbles.
Oh, okay.
We're fine. So 39.
That's what I'm aiming for.
So we started off at 38 and a half. Okay, so we're gonna now take just simply a regular, very normal, very simple anything here. Flask is fine for a narrow neck that's broken and as a safety hazard, but okay.
But like, yeah, when do we close?
Yeah.
But seriously, like that's all we have.
No goggles, no flash, no
Oh my God, these people.
These people.
No, this is nothing compared to yesterday. Extra help. Don't worry.
So
Oh, you don't want to know.
There's no measurement on
Fire. He got jail cards. Like,
No.
He was playing all the time.
There's no measurements on
Bro,
it.
he almost went to jail.
I don't think we've been around.
We do, no. This is classified information. Now this way, we got you. We'll stay quiet.
Right, because we don't snitch, right?
We don't snitch.
I'm never skipping extra help ever again.
This is never gonna happen again. That just means you'll be extra careful, bro.
Alright, we don't snitch, right?
No, we don't snitch. No.
Alright.
She called CPS.
okay, guys. So what we have here is 38.5. We have 38.5 of the acid. Initial 38.5 of the acid. We're gonna see. We're gonna put a couple of drops of the methyl orange, methyl red. So a couple of drops of the methyl red will make this. We'll make this red exactly.
No way.
All right. We're gonna take. So we're starting off at 38 and a half. I'm just confirming multiple times. We're starting off at 38 and a half. All right. We're gonna go down to how much do you want? 47 and a half, 10 milliliters?
No, it's because
All right,
so
we're go-
that's 38 and the rest is
Starting off at 38 and a half, we're gonna go all the way down to 47 and a half.
it's opposite.
Oh.
What sense?
38 and a half, go down to 48 and a half? Yeah, 48 and a half, sorry.
Yeah. Oh, y'all gonna make fun of me,
just
right?
10
See, we caught you this time.
We get calm down too much in school.
It's very viscous.
Those from Disney.
Resistance to flow.
Oh.
High LPS.
So we went down to 48 and a half. Okay? This is how much peach juice we use. We're gonna need a couple of drops of
How many drops? 3, 4?
it really doesn't matter. So
Oh.
now it's very red, as we guys can see. It's very red.
We'll count that as like 6.
Okay. So
One whole pipette.
clearly red, right?
Yeah.
It's a cocktail.
Totally.
So how much milliliters of the peach tea we used?
10.
So we went from 38 and a half to 48 and a half. That is 10 milliliters of peach tea. It's very red, right?
Yeah.
So right now, the initial of this 0.5 molar NaOH is, I don't like this initial. What did I use for this? I used this thing, right?
Yeah.
Alright, so we're gonna just bring it down to 15 so we can start at an even number. Okay,
We gotta be sure it's reading it right.
that's 15.
That's 15.
That's see the meniscus?
Yes.
Yeah, but
That's
it's
very
also kind of
clear.
sideways.
It's still
That's still 15.
15.
Still 15.
Alright, so this is just extra base. Now we're gonna try to drop the base until it turns back what? Yellow again, right?
Drop the base.
This is a 0.5 molar base. Alright, so this is gonna be quick. Hope not too quick. So we started off at 15.
Look. I see a little bit of yellow.
But you don't. Where do you see yellow?
Came out a little bit, but not much.
You're not to ever walk around.
See the yellow, but
Oh.
disappears. Oh, there we go. That's all we needed. It's yellow again. That was the normal color of peach tea. Make sure you do this again. How much did we use?
That face was too close to my face.
Our initial was 15 mils.
Hibba's face is gonna be.
Our initial was 15 mils. Our final was, can't see this,
15.3.
15.8.
So we used 0.8
I was so close.
We used 0.8 milliliters.
NaOH.
15.8 exactly. 0.9.
So close. I said 15.3.
15.8 is what we used. We used 0.8. Sorry. Okay. For that, so that's your calculations for how acidic. Let's do this one. Let's do this one together. So we don't know the acidity of the peach tea, right? We don't know the concentration of acid in the peach tea, yes?
No.
All right, so Ma multiplied by 10 milliliters. Ma multiplied by 10 milliliters
Divided by 10 milliliters.
equals 0.5 multiplied by 0.8, right? All right. 0.5 times 0.8 divided
Molarity of
by
acid. 0.5 times 0.8, 0.04. 0.04 divided by 10.
so 0.04.
No, 0.5 times
So now we got
0.8,
0.04, which we are going to. So this is milliliters. This is the molarity multiplied by milliliters, right? We're going to take that 0.04 divided by. We're going to divide it by 1,000.
Oh, is this
Because molarity is per liter, right? Molarity is per liter, and what we were using is milliliters. So take your 0.04 divided by 1,000, and that gives you the H plus ion.
That's 4 zeros.
So you have 0.40 is 4. 0.00004 is the concentration of the H plus ions. Understand? And now, using your fancy calculator, you are going to take the log of that,
Flip it to the side, baby.
and you're supposed to take negative log of that, but if your phone doesn't have a negative, it's gonna read error. iPhones don't have negatives, so it's gonna read error. So you can just take log of, log of 0.0004. Okay.
How many zeros?
And
4 after decimal.
4 zeros and a 4 after.
it's negative, right?
And then you will get a negative number if you just take the log. You take the absolute value of that, and that's your pH.
So 4.4.
So this is a very acidic juice you're drinking. It has a pH of 4.39.
4.39.
4 point what? 4 point,
It's close up to 4.4.
4.3, 4.39, 4.4.
Why's the color getting
Wait, why did we divide by 1,000?
Because divided by
That's just
molarity
the-
is determined by liters.
What did you get?
Moles over liters. Joshua,
says
didn't we
that,
do it the opposite of way around yesterday?
What, Snapple, peach tea?
No, but like
Well,
we
that's
already
not
have.
true, because what we got is what we got.
No, but this is
All right.
milliliters.
So, we did use a very.
Wait, Dr.
She said.
Philippi.
So she said peach tea has a pH of what?
2.94.
2.94. She said, according to their claim, the pH of peach tea is about 3. We got 4.4. All right, we can repeat the experiment. We have some left to repeat the experiment.
Dr. Sawyer,
Yes,
was
ma'am.
there a calculation error? Because we did 0.8 milliliters of NaOH. Shouldn't we divide that by 1,000?
Well, I divided everything by 1,000 at the end,
Okay.
right? At the end, I divided because
Yeah,
you
but-
got a 0.04 as an answer. You got the
Yeah,
when you do
0.04.
solve for x, you get 0.04.
But isn't that already the molarity?
The molarity is per liter. You're multiplying it by milliliter, so you take everything and you divide it by 1,000. The molarity is moles per liter. That's what molarity is. But what do you have in here? You're measuring milliliters.
Yeah.
You get it? So if you want to calculate the H plus ions, the H plus ions will always be per liter.
Okay.
So the concentration of the H ions has to always be per liter. Okay? So therefore, you have to divide your final answer that you get there by 1,000 to get your concentration per liter.
Okay. I think it's close.
All right?
Okay.
If you did it before, you
All right.
did the same answer. If you did it before, you did the same answer.
Oftentimes, the concentration of H will be given to you. This is that situation where it's not given
She
to
said
you.
that if you converted this to liters, it would be the same answer.
Wait, no, ml. The 10 is an ml.
This table so low, I can't leave it.
You said, what is it? What did it come up with to be?
2.94.
2.94. All right, we are going to repeat this experiment one more time. we're going to repeat this experiment one more time with the peach juice in order to kind of like make sure we have
He's not gonna use clone
I know, I've given up.
Yeah.
to make sure we have a set number, a definite number. So,
That's not a definite number.
all right. So,
That's
No, I can see everything.
Bro, you're just recording the talk in this
No, I can see
You
everything.
multiply these divided by 10, and you divide by 1,000 because it's over liters.
So why are we? No, I meant. why are we
Okay,
dividing by
I'm doing
1,000?
it
Why
again.
isn't it just 0.04? Because in here, it was in milliliters, but we still kept the milliliter.
if you do it in
We didn't
milliliters,
divide it here by
Okay.
1,000.
so we're gonna repeat it again and see what we get. All right, one more time, same exact situation. We can use a different one.
That's
I
what I was
do have a
confused
different
about this
one.
part.
We should wash this stuff in the same.
So
No,
here
it should be this way.
I have. This is not
I don't think that's how
0.04.
it should
This is not
Because
37.
then if you do that, 0.4 divided by 10.
Why do you look so menacing?
You got all this. It's like an angry.
All right. We're gonna go from 37. We're gonna go from 37 to 50. All right, 37 to 50 this time. We're gonna use all of it because it's the last time. So 37 to 50 is gonna give me how much?
13.
13 milliliters. 37 all the way down to 50.
Would like an unclean like flask like that
Yes,
add
it
to
was
like
in
the
it.
percent?
It's only dirty from the outside.
You dirty from the outside. That
We
should be the
didn't
name of the book.
add the thing right after, right? We added it after we had added all the solution.
No, we didn't.
Really?
This is what we did.
Stop goofing around, Mohammed.
Why are there papers on the floor?
Why not?
Okay,
I said, I know.
37 to 50. So now we have 37 to 50. How much did we use?
13 milliliters.
13 milliliters. And now we need a little bit of the methyl red. I need to keep this in one place.
It's the other one.
I don't know which one it was.
There's plenty of spare.
Okay. So now we're gonna
Oh, well,
drop
you know
the
what's
methyl red
like
in here.
assembly.
It's fine. Doesn't matter. This does not take part of the reaction at all.
Okay.
Okay. So this is methyl red in case I have to use it again. Let's keep it here.
Mom's bro.
Methyl red. Okay. Very red. Let's see how much we need. We're gonna repeat that experiment one more
How
time.
much is the initial?
Right now it is sitting at what we said before, right? What did we say? 15.8?
Yep.
Mm-hmm.
Okay, it's sitting at 15.8. Let's see how much we need. This is gonna be very quick. So I put a drop. Nothing happened. Try again. Another drop.
Something's happening.
Almost there. Still red, right? We all agreed
Yeah.
still red?
Yeah.
Put another drop.
Okay.
Is it there yet?
No.
Almost.
A little bit more.
Maybe one more drop, right?
Yeah. Why is it?
It's kind of yellow, but it's not the same color. It's orangish, right?
Yeah.
Yeah. Okay. We put maybe one more drop. All right, now we're at there.
Yeah.
We're there?
Wait, we still need a little more.
It's a little.
A little bit.
No, no, a little bit. This is yellow.
This is yellow.
This is the color of this.
I can taste this.
Oh.
Let's taste it.
Is it the same color or am I? It is the same color. Same exact color, right?
About the same. It has some red spots.
It looks dark from this side, but like from there, it looks.
If you put them both together like this,
Yeah, it's the same.
exact
It's the
color.
same.
It just looks red.
All
It's
right.
like red.
Any more than that, we would have been a false result. So we used. We said 15. We said 15.8.
Yeah.
We came down to 16.6.
Yeah, 16.
So
Called it
0.8.
0.8,
0.8 again.
15.8 to 16.6.
Wait.
0.8.
But didn't we use more?
We used 0.8 last time. So.
No, I'm saying.
Yeah, but we used less acid last
Yeah,
time.
that's what I'm saying.
Yeah.
So this is more accurate, I think, because I really try to drop a little bit at a time. So where are we at now? So where are we at?
MA times 13 equals 0.8 times 0.5.
How much we had used? We had used 13 milliliters of the acid, right? So MA times 13 equals 0.5 times
0.8.
0.8. 0.5 times 0.8 divided by 13. And then take log of that, log of 0.03. I will get 1.
Like I said, disappointed everyone.
0.5 times 0.8 divided by 13.
It's still 0.5, right?
Yeah. Divided by 13. And then log.
Sorry, but I had to. You know, I'm making
She has like 7,000 facial muscles.
No, I'm making a collection.
You don't convert it to liters? You don't convert it to liters?
So you solve for
Wait, who cheated on the
but it's in milliliters. So
Oh yeah, I see.
What'd you get for a pH?
Like 4.5.
4.5? All right.
I'm gonna just talk to him after school. 4.5.
According to this, Snapple has a pH of 3.32.
So what's the winner?
Wait, is it diet?
No, it's regular.
Okay.
What's the what was the pH of the
It'd be like the actual?
All right. All right, we're good. So the pH is about 4.5. What was the first one we had? Excuse you. Can we stop talking, please?
It was 4.4.
You're getting really annoying. This is not an entertaining socialization. I'm sorry if you're lonely, but try to get a life. Stop talking, man. Let's focus. It's a lab. We're doing a lab. Sorry, that was harsh. But seriously, stop talking. You guys can't stop. Like, focus on the lab. You're trying to learn something. For some of us are thinking about what it is. So what was the first result that we had? Try to participate. 4.4. The second time we got
4.5.
Okay, so take the average of that is 4.45. That's the Snapple tea. All right. Now we're gonna try to do the same thing but with soda. Toss this in the sink for a second. I shouldn't even be doing this entire thing with you. You're supposed to do this entire thing by yourself, from scratch. All right, same kind of thing, same kind of concept. But now we're using soda.
That's so weird how it's so off.
Where's the funnel for the soda that we use?
Because that's at least a 50% error
All right.
Which one?
for Snapple.
So we're gonna use
No, it's
soda
like
for this.
25%.
No, original was 2 point something.
Whatever is online is not accurate according to what we have. Which Snapple tea do you have? Where's the bottle? You have just regular peach Snapple tea. I mean, you have to also to keep in mind that different batches will have different acidities, right? They're not gonna make exactly the same thing every time. This is human made. Okay, so
Yeah, it says 2.
the problem with soda is the bubbles.
Yeah. Oh yeah.
It's gonna be pretty much primarily bubbles. All right, so
You're gonna get a hefty error for that.
you gotta really wait for the bubbles to kind of clear out. All right, so we'll wait for it to all clear out, and then that's our soda. Soda has both phosphoric acid and carbonic acid in it. It has a lot of acid in it.
I did it. Let's go.
Oh, that's for one of the questions in the assessment. It asked you like, what's the? You asked me what the
All right.
primary acids were, so it's carbonic and phosphoric.
Yeah, the two acids that are in the soda are carbonic and phosphoric. Okay. This is definitely going to take more of the 0.5 molar.
I think we could search that up.
Here's a clean flask.
This will be. Isn't carbonic acid used to make it the fizz?
Yeah,
Yeah, and phosphoric is for the flavor.
phosphoric is for the color, yeah, and the flavor, yeah. It's both. Where are we at? We're at 31.8.
Yeah.
31.8.
We love our 0.8s.
Okay, 31.8. Where do we want to come down to? Let's go down to 41. 41.8. From 31.8 to 41.8. We're good? Or do you want to come down a little more?
No, we're good.
I wanna. Okay, so we can have enough for the next one.
Yeah.
31.8 to 41.8. Wow, this moves very quickly. You know why it's moving very quickly also?
Yeah.
The gas is pushing it down.
Would this change if we would like the results change if we had like a flat soda?
Yeah, definitely the results will change if you have a flat soda. Less carbonic. Well, no, the carbonic acid is already in there, but a lot of it will come out when it, yeah, it will change slightly, not too much. 41.8, 9.8.
Wait, so does the peach like have more sugar than the soda?
Maybe, perhaps.
Yes.
Yeah.
Oh, actually, I don't know. They both have a lot of
They both
sugar.
have a lot of
We
sugar.
can read the label and see.
But also it's Snapple, so it has more glucose.
Because I noticed that the
This one
peach was a
has
lot more
40
than
40 grams.
the
They're
soda.
about the same.
All right, I'm gonna come down to 42.
42.
Let me see. Just make sure I get it right.
You're gonna have a decimal.
All right, 42. Yeah.
That's fine.
So 10.2.
No, I came down. So 31.8 to 42.
So
Okay.
10.2.
31.8 to 42. That's my soda right now. We're gonna do the same thing with the methyl red. 31.8 to 42. We good? So how much did we use?
10.2.
All right.
Should we just plan the procedure generously?
No, I really want to see the color though.
I
That's
think we still do have to add the number.
Yeah,
because
that's
it's
right.
Oh,
Like in my
generously
soda.
add the thing on
What is
so you can
document?
see no change in color.
It's red, right?
Yeah.
Yeah.
Okay.
You have to be very clear.
The amount of drops that you add doesn't matter. You have up to 10 drops and still be fine. All right, very red. We have to compare it with the actual color of soda. So this is what we know. Let's have another flask so we can know where our end point is.
That's the peach tea.
Is this
Yeah,
soda
I'm gonna
provided
put
by
these
the
together.
school?
Nope, that is provided by Vivian.
Good job.
Okay,
No, thank you for the tea.
now let's see again.
How much is it? The initial?
Wasn't it 16.6 from earlier?
Yeah, 16.6.
Okay. You can spin this so this goes to stay here.
Oh,
You can spin it so that this is on top. All right, so we're at, what did we start with again?
16.6.
16 points,
Well, we're at
16.6.
Yeah.
Okay. Let's see how much we need. No, No, not there yet, right?
Yeah.
Oh,
Much
it gets
darker.
darker.
That's much darker.
This is much darker.
Interesting.
Getting there.
Definitely getting there. Almost.
Not there yet,
Yeah, just a little bit more.
right?
Yeah, it's still
Yeah.
kind of red.
Because that's still a little darker.
Still kind of red. That might be
And still, no.
still red. It's kind of light.
This one is a lot darker. Am I right?
Yeah. that makes sense.
Yeah. Yeah, that's a lot.
I don't know if it's darker because the light isn't going as far. Or...
No, it's darker.
If you put it at an angle,
Still
you can
darker
tell it's.
there.
It's definitely still darker.
It might be dark because there's.
Yeah, we are.
I
Just a
just,
little more.
yeah, that's what I thought, but I just took a
Yeah,
lot.
it's literally almost equal to. That's
No.
Still not there.
That might be it.
No, I think we need a bit.
Just a bit
It's a
more.
little red.
just a bit more.
It's gonna be the same color. Soda's definitely more acidic right now.
Yeah, that looks good.
What are we writing the procedure? Just keep adding until.
Yeah, until same color.
Ah, and then you have to keep
Yeah. That's what I put.
agitating the solution
Agitating the solution. Why'd you get British?
because I think Dr. Salubi is British.
You think Dr. Salubi is British?
Got colonized by the British, but that don't mean he is. He's from Jordan, that's a fact.
Okay.
Like you weren't colonized by the-
True, I didn't say I wasn't.
Exactly.
Yeah, I got this on video.
Oh, that looks about the same.
No, not yet.
Me too.
Good morning, students. Again, today's a D-Day. Just
I
want
feel like he's like about to announce crisis or something.
I know.
Good morning, staff. Good morning, students.
End of the world is here.
The bird.
The
Doomsday
world
is
is about to
here.
end.
Jesus is outside.
Yo, whole suites might as well be living
If you receive your high school student, you will be given a warning. Second,
What if
you
you
will,
go
your
Those are the
parents
same things.
Oh, you're going to do
Me and Jonathan,
You're going to the dungeon. You're going to the dungeon.
I feel like it's getting lighter.
That's right.
It's not changing.
That's in Guardians.
Yeah, for real.
you are grade
Then we're gonna try to be like so long.
you found the senior hall. Rise fast and that will lead to disciplinary action. If you're a senior and you're in the senior hallway and you do not belong there, that is also cutting and disciplinary action will be dealt with. We want to keep our hallways clear.
All right, I'm looking at what did we start with here?
16.6.
Stop threatening people. That doesn't work, man. Please.
High school or middle school.
What did we say? What is
16.6.
That's like 22.
16.6 and now we're at what?
22.6.
21.5. 21.6?
Yeah.
16.6 to 21.6.
Oh, that's good.
5 mils.
That's pretty good. That's a lot. That's pretty good.
Yeah, 16.6 to 21.6. That's really where I'm at. I can repeat this one more time to see where I'm at, just to make sure
Let's just.
we get whatever we get.
10.2.
Gotta repeat this one more time to make sure. So we're gonna go with,
Do you write that as part of procedures? Repeat.
what was the end here? That was 42, we ended at 42,
I
right?
did that. I
Now
did
we're gonna end
titration
at
number 1,
50,
titration
so that
number
gives
2.
us 8
Good.
milliliters.
Okay. So that's less.
You're smart.
Thank you.
Just like how I raised you to be. That is a lot.
What was the indicator that we used?
No, I'm saying
Methyl red.
Oh,
All right, we're ending at 50, so from 42 to 50, we're repeating the same thing again. We are going to use
8 mils.
methyl red one more time. Okay.
You get it?
Methyl red, so here's how methyl red works. It will turn yellow when the pH goes above 6. Okay? And what is it? Methyl red. So methyl red, it's most effective when the pH is less than 4.4, because it's red when the pH is less than 4.4, and it is yellow when the pH is above 6.2.
Is methyl orange and methyl red the same thing?
Same thing, just a different range. So let's see. So we already established that this is definitely has a pH that is, this is the second trial. Second trial, we used only from 42, we used 8 milliliters, right? From 42 to 50. Okay, that's red.
Yep.
It's best to look at it like this against your hands. This is yellow, this is red. Yes?
Yeah.
Clearly, we can see that.
The undertones.
All right, we're gonna try the
Second trial.
second trial. We used 8 milliliters, and we're going to start with. We're starting with, what did we end with? 21.6?
Yeah.
Yeah.
Let's make it 21 exact. I hate these little numbers. Which one was the thing? I think it was this one. Make it 22 exact.
22. This is gonna be the longest procedure ever. This usually take up like 10 pages.
Okay, 22.
Yeah.
You got 22
Results might take a
milliliters.
long time, too.
Yeah.
We're starting off at 22. This is the red one.
Yep.
Let's see how much we will use.
Not really. I just have to rewrite the same things. I'm just gonna change the numbers up.
I know, but it's like you're playing The Sims.
You're playing Sims?
Yeah, right?
What is like playing Sims?
It's like write the procedures out. You gotta like think, oh, gotta do that.
22.
I don't think you do that in The Sims. What Sims game are you playing?
She's playing BitLife.
Rose playing Sims 0.
Yeah.
That was the beta.
That's yellow now.
Yeah.
Yeah, that's yellow.
That changed very quickly.
What did we do wrong the first time?
That's very interesting.
Yeah, that is very interesting.
That's very, well, we have less this time. So we used 22 to 22.5.
That's 20. That's 22.
That's 0.5.
0.5, look at the meniscus.
It's 5. Yeah. Never mind. Sorry.
So we use 0.5. So we use 0.5 of 0.5 molar. 0.5. So you're gonna do, so technically you want it per liter, right? So you're gonna do 0.5 divided by 1,000. Okay, multiplied by 0.5, and then divided by, what was, how much did we use? 0.8?
Yeah.
So it's 0.8 divided by 1,000 is 0.0008.
0.8. Where did 0.8 come from?
We use 8 milliliters.
So we used 8. 8
Yeah.
divided by 1,000 is 0.008.
Serotonin, the one thing I don't have.
Right? Yeah? And now we're going to have the molarity is going to be 0.031. 0.03125, right? We're going to take the log of that, negative log of that, negative log of 0.0, what did you guys get? 0.031? 0.031 what?
2.5.
25?
And you get
0.03125, we got a 1.5. That's freaking acidic, man.
Yeah.
Is
Yeah, you
that?
drank some of
the
that.
listed online is 2.37.
Yeah. But we've already assumed that.
Lying, bro.
But because there's different.
What did we get the first time?
The first time, let me calculate it.
I got a pH of 1.5 for this soda.
Vivian, you're like killing your throat.
So we're like from
Killing your
4
throat with
to
that soda.
1.
More
I don't
acidic
drink
than the
soda.
hydrochloric acid in
Why
your
do you
body.
want this one?
My mom drinks it.
So this is
My
pretty
mom
bad.
drinks it.
Anything that's less than 3 is bad. Vinegar is less than 3. Soda is less than 3.
My tea is less than 3 sometimes.
Occasionally.
Acid. So we gotta talk about why acid is bad for you. When you ingest acid, you're first of all you're gonna reduce the amount of hydrochloric acid that your body will naturally produce in order to digest the food, right? When you ingest acid, what happens is it reduces this kind of acid, not the regular citrus fruit acid. It reduces the oxygenation in your body, the oxygen in your body. Less oxygen in your body results in deprivation of oxygen from the tissues, right? So now your tissues aren't getting enough oxygen. If your tissues aren't getting enough oxygen, your tissues are going to start competing for oxygen in order to survive, natural human survival. So when your tissues are competing for oxygen to survive, now that's how they begin to multiply, and excessive multiplication is kind of like defined as cancer. Get it? Yeah. So too much of that stuff increases the risk of cancers. It also all this fake sugar that's in it, like lots of high fructose corn syrup in here. This fake sugar in it also increases the risk of diabetes by a lot. Okay? So there are 39 grams of sugar
But it's fake sugar, so it's
in here, and it is not good sugar. It has high fructose corn syrup. High fructose corn syrup is very unhealthy for you. No one should be drinking that high fructose corn syrup. Most of these drinks have high fructose corn syrup. Snapple is the only one that uses regular glucose, regular sugar. But they use how much in it?
40 grams.
40 grams. 40 grams per what? Per one bottle.
2 was the amount we used
40 grams of sugar is a whole lot of sugar
for that.
in a bottle.
And then times this.
All right.
No, it's
And
39.
I think at this point we have
0.05 divided by
done
10.
this lab to the best of our ability. So now we're gonna go to the seat and we're gonna try to answer all our questions.
So for
Okay,
the first try, I got 0.6.
Now I want to drink again. Let's go.
I'm asking about this.